This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com. This episode of Know-How is brought to you by Eero. Never think about Wi-Fi again with Eero's hyper-fast, super simple Wi-Fi system. And now, the second generation Eero is tri-band and twice as fast. For free overnight shipping, visit Eero.com, select overnight shipping at checkout, and enter the code KNOWHOW. And by FreshBooks, the ridiculously easy-to-use cloud accounting software used by over 10 million people. Try it free for 30 days at freshbooks.com/knowhow.
Today on Know-How.
Time keeps on spinning. LED clock, part 4.
Welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Ballecer.
And I'm Brian Burnett.
And for the next, I don't know, hour, 45 minutes, 4
2
hours, who knows?
3 days.
We're going to be taking that mason jar that holds all the knowledge, open it up, and cramming in some more preserved knowledge.
That's right. It's going to last. It's going to stay for a long time.
That's right. We are nuclear knowledge preppers here. Actually, you know what? I've always wanted to make that one of the Know-How segments, like canning. Seriously, there's like an art to it.
Yeah.
The thing is, I don't particularly like canned foods. I don't like canned vegetables, canned fruits.
Well, we could can anything. There's no limit to canning. Yeah.
Well, I mean, no, there is when you run out of space. I have an uncle who he loves canning the fruit that he grows because he loves growing fruit, but he doesn't actually eat it. Mm-hmm. So like the lower floor of his house is nothing but those little mason jars. I'm like, well, I mean, okay.
Yeah. My mom used to make jam back in the day and stuff. The canning that I like to see, they're actually called crowlers. I think it was during the beer episode that I did for Know-How.
Oh, right.
Where it's canning, but you fill it with beer and then it crimps the top, and then you've got like a liter of beer.
I guess it does sort of appeal to the fastidious part of your mind where you're not wasting anything. But yeah. I gave my uncle a solid note of advice, and that is, if you're still canning fruit that you have canned from 8 years ago, stop canning it.
It doesn't go bad, right? Like, don't you want to save it for the zombie apocalypse?
Do you want to be eating the 8-year-old canned fruit?
I don't think I'd want to eat the canned fruit even if it wasn't 8 years old. As soon as it goes into the can, it feels unappealing.
Oh. Well, we'll probably do that at some point. But Brian, this is not a canning episode. Wow, we got off on an early tangent. That doesn't normally happen until the end of the episode.
Yeah, that's all right.
That's right. Well, we're going to be doing the part 4 of our LED clock. Now, we've been having fun with this because it's shown us some of the basics of 3D design, when you want to put together a project. It's shown us a little bit about WS2812, soldering. This is from a ground up project.
Yeah.
Nothing has existed before we started putting it together. And yes, it's just a clock, but at the same time, it's such a pretty clock, Brian.
It is a very pretty clock. And speaking to how sometimes you're not always the most artistic person.
No.
I feel like you did a really good job on this project.
It's got twisties.
It's got twisty pillars.
Look at this. Here, actually, could you bring the lights down, Alex, so that we can show them the full... actually, go to the overhead. You have to go to the... There we go. Oh, look at that.
Yes.
It's pretty.
Functional, and it lights up.
And, of course, we've got the special modes on it. It's funny because I actually have one of these. I'll be showing it off next week. Mm-hmm. It's a different style of clock, and I probably leave it on this mode all the time, which is not a very good clock.
No, but it looks pretty.
It does. Well, but that's what we've been doing the last couple of weeks, and we've got this episode and the next episode. So in this episode, what we're doing is we're showing people how to assemble the base. We've already shown them how to design the parts. We've shown them how to assemble the LED ring frame.
Right.
We've shown them how to program the thing. Mm-hmm. Now we need to put together the electronics that are going to actually drive it.
Yeah, and my favorite part about this whole project is that every project that you've done in the past has kind of been leading up to this.
Yeah.
Like it's incorporated almost everything that we've talked about.
Well, that's what we want. I mean, that's the best way to learn, right? You just add a little bit. We learned about some Arduino stuff. We learned about a little bit about RTC. We added the RTC. We learned about how we control WS2812s. Mm-hmm. We just kind of put everything together and came up with our clock.
Yeah, it's cool. And, added benefit, it lights up, which
It does.
appeases us.
Oh, well, come on. Well, a few months ago, Maker Faire, right?
Yeah,
We
the
walked
dark
into
room.
that dark room, and it was like, yeah, there's so much beautiful technology around this place, and people love
It's
the lights.
If it just lights up, it's moths to the flame.
It's a thing, right? But let's go ahead and break down what we're going to need for this. I know that you received this list of parts before, but we want to be clear that when we did the large list at the beginning, that was for the entire project. We've been breaking them down into the small sub-projects, and we've been giving you the time. This is why we've spread it out over 5 weeks so that you can actually assemble this in real time as we go. The first thing you're going to need, of course, is an Arduino Nano. Of course, we've got a link here. If you buy these in bulk, you can get them for about $3, which is what you're gonna want. So go ahead and buy like 10 of these things. You're gonna use them. I mean,
Yeah.
we've never not used Arduinos that have been in our inventory.
And then it allows you to, if you make a mistake, or you step on one, or you spill a cup of coffee on one, you got a backup.
Right.
Not that I've done any of those things.
Second piece you're going to need is an RTC, the real-time clock. And again, buy these in bulk. If you buy these in a 5-pack, you can get them for about $1 a pop. I actually bought it in a 50-pack because, yeah.
And if you buy all this stuff at once, it gets shipped together, right?
Get shipped. No. That's the thing about Banggood. I like them. I've never lost anything from Banggood, but like I've made one order and half the order will arrive in 3 days and the other half arrive in 3 months.
So plan it out.
Plan way ahead. The other thing about the RTC is you can almost count that on the battery that's included with the RTC, the CR2032. It's gonna die or it's already dead. So just go ahead and buy yourself a pack of CR2032s from Amazon, like it's going to cost you $6, but it will allow you to put a fresh battery in there because remember, the RTC is what allows us to keep time even when you unplug.
Right, which you're going to do eventually.
Which you're going to do, right. You're also going to need UBECs, Universal Battery Eliminator Circuits. Now, we have been using these. These are Hobbywing 3-amp UBECs. We're going to talk a little bit about the math. $3 a pop, however, I kind of like that we're going to be doing a dual power supply system so that we can supply power to either side of the ring. And I had these already, so I used 2. You could use a larger one. You could just get like one 7-amp one, which is actually about the same size as 2 3-amp UBECs. But again, they're going to be about the same. So go 1, 2, whatever you want. It's all up to you. You also need a power jack. So this is a 12-volt power supply. This is what's going to give us the power that the UBECs are going to turn into 5 volts. So I'm starting with 5 amps, 12 volts, which is 60 watts. So this thing can provide me 60 watts of power. That's going to become important a little bit later on. And you also need something to plug that into. So I've got this. It's a power jack socket. Now, this is the version I originally wanted to use. This doesn't quite work with this design. I mean, it did, but I didn't like how it looked. So I went with a pigtail, which we will leave in the show notes. You can choose whichever one you want to use.
The freedom of choice.
Freedom of choice. We love that. You're also going to need some 10K resistors. Now, here's the thing. You don't just buy a couple of 10K resistors. You have to buy them in packs.
Might as well.
Yeah. Buy a 50-pack. Actually, I bought a 1,000-pack because I go through these things a lot.
Is that a common resistor for you to use?
Anytime you're doing input with a button on an Arduino, you're going to need a 10K resistor.
Right. We've talked about why you need a resistor for the button. Okay.
Well, and the other issue is normally when you buy these, all from Banggood to Amazon, they want you to buy like the budget pack, which has 1,000 resistors, but only 50 of them are 10K. They give you a bunch of different values.
Oh, I see.
And I have all the other values. I have packs and packs of these things. I just needed the 10K I was running out, so that's why I bought a big old allotment.
Right.
It cost me like $15.
It's not that bad. You'll have them forever.
Exactly. Well, no, literally, I will have them forever. You're also going to need some push buttons. Now, these are the ones that I'm using. These are inexpensive. You're only going to use 3 of these things, but go and buy yourself a 20-pack. It's going to cost you $1.88. These are the right size to fit into the 3D casing. It's 12 by 12 millimeters, and that button will just fit through the 3D designed button holder.
Nice, yeah, and they have a good button feel. They have a nice little clickiness to them.
Tactile. It's like little cherry switches.
Yeah.
Yeah, how about that? Also, something new for our projects, diodes. Now, we've talked about this before, and we're going to be discussing it when we get to the actual assembly of the base. But we want power to run to the Arduino, but we do not want the Arduino to run power back. It was okay, we could get away with it when we were doing just like the goggles with, 20, 30 LEDs.
Right.
We've got considerably more LEDs this time. If that Arduino Nano tries to power all of those lights at full intensity with just the power it's getting to the USB port, you will blow it. It will burn. It will just get really hot and then stop working.
You sound like someone who's found that out from experience.
Well, remember the Aquavase project?
Yes.
That got really, really close. And like the Arduino, the Nano actually started melting through the PLA.
Oh, wow.
That's how hot it was getting. Yeah,
okay, so you got to be careful with that.
Yeah, and what the diodes will allow us to do is we can put them in line, and they will allow power to flow in one direction but not the other. So it will allow power to flow to the Arduino and the switches, all
Just
the logic.
not back out.
Just not back out. So
Okay.
when you plug a USB into the Arduino will power so you can program it, but the lights won't light up.
Okay, smart.
The other thing you're going to need are jumper leads. These are super useful, all-purpose. Get yourself a set of 400. That's 200 black, 200 red. These come in very, very handy. And of course, some silicone wire. I'm a big fan of 30-gauge silicone wire. It's, just get a couple of spools of this stuff because it's always going to come in useful. It's always going to come in handy, and it's very inexpensive.
Penny for scale.
Penny for your thoughts. All right, let's talk a little bit about the 3D pieces we need. Again, we gave everyone the whole pack of STLs at the beginning, and that's a lot. It's a day plus of printing. Actually, no, multiple days of printing. This is going to require 7 pieces. So if you go to the overhead, Alex, or that side, this is the main piece. So this is the base. Now, if you want, you can take this design and cut it up in any way you want. And remember, I also gave you the hollow. So if you want to design your own base, you can. It just has to be able to fit, or whatever that is. Actually, if you could go to the overhead. Thanks, there you go. Now, there's a couple other pieces here that we need to play with. This is the button cover. So this is gonna go over the little center channel here. It just fits right in, and this is actually what's gonna be holding my buttons when I solder everything in. Of course, I've got 2 cable channels on either side here. These are the ones that are gonna hide the wiring that are gonna go up into the columns. And then I've got the cable channel covers. So these just snap over the top, so I get that nice clean look. Now the last 2 pieces are these. These are going to be the end caps, and unfortunately everything is side sensitive. So there's a right side and a left side. So Alex, if you switch back to the other side, there we go. So this is what our design is going to look like. Another feature of this is the fact that these columns, let's see if I can are actually hollow.
Ah, yeah, save on filament.
Yeah, that's where I'm going to be driving my wiring up through.
That too. Okay.
Yeah. So that's everything that we're going to need.
And the spiral, that's just an aesthetic thing,
That's just
right?
an aesthetic.
Yeah,
Well,
that's
because I could have just made it square. I could have made it circular, but then there was a thing on Tinkercad for spiral. I'm like, oh,
cool. Yeah, give it a shot.
spiral's cool.
Nice.
Let's do that. So let's talk a little bit about actually designing this thing.
Okay.
Because it's not as simple as just slapping it together if we want to maintain safety. Because again, we're dealing with a bit more power than we normally have in our Arduino projects. There's a total of what, 86 LEDs.
That's
Because
pretty
I've
good.
got 60 in the LED ring, and then I've got the 2 9 and the 6 and the 2 array.
Right.
So that's 86 LEDs. Here's the thing, those 86 LEDs at their max, so if you turn them full brightness with all 3 colors on at the same time, they draw about 60 milliamps.
Okay.
Okay. Now you multiply that by 5.1, so you multiply that by the number of LEDs you have, and that's going to be pulling 5.1 amps. You multiply that by the voltage, which is 5 volts, and you're going to get 25.5 watts. So this thing's going to draw about 25 watts at its maximum.
And so with the power supply that you had talked about earlier, that was more than enough.
More
Yeah,
than enough.
60 watts is what it would provide.
But here's the thing. We always put a safety margin, because whenever they say something is rated for a certain wattage, we just kind of assume that that's plus or minus. The plus or minus should be 5. I like to be a bit on the safe side. I make it plus or minus 20%.
Okay.
So if we want a 20% safety margin, that means we're adding about a 5-watt safety margin. So we're talking about 30 watts that this is going to draw.
Oh, okay.
Yeah. At its worst case scenario, but that's what we want to design it for, because we want to design it so that no matter how you use it, it's not going to burst into flames.
Yeah, or melt the Arduino.
That's a feature.
Yeah, it's not a good feature.
It's a total feature. So we need a power supply that can supply 30 watts, which we have it. We talked about that before. We've got a 5 amp 12 volt power adapter, so that's 60 watts. Okay, so I've got 60 watts to play with, but it's 12 volts. I need a way to convert it down to 5 volts.
Right.
That's where we use my those UBECs. So the UBECs will take any voltage between 6 volts and up to 28 volts and convert it into 5, always into 5, which is what I need. That's my nice clean power.
Okay, and what if you wanted to use a battery for this project? Could we use one of those LiPos that we had for like the quadcopters and stuff?
Those are 3.7 volts. Those will just drive it, but you'd have to direct drive it. You could not put that through the UBECs. The UBECs will see 3.7 volts, and they'll say, no, can't do anything with that. It's got to be at least above 5.
Okay,
yeah. You could power it, however, through the power plug, just using like the quadcopter battery, the big quadcopter batteries, because I can give it 7.4 volts, I can give it 11.1 volts, I can give it 14.7 volts. All the different voltages I've got from those LiPos, this will turn it into 5.
Okay. Yeah, I was just thinking of like a portable clock.
Yeah, so you could wear around your neck.
Yeah, exactly. Flava Flav style. It's got LEDs. It'd be cool.
Ladies and gentlemen, Cranky Hippo. Okay.
Continue.
So let's go ahead and talk about the UBECs, because I've got these wonderful little things that I've been using in so many projects. The thing is, these are 3 amp. 3 amp, 5 volt. So remember, I can find watts, West Virginia. Watts equals volts times amps. 5 volts, 3 amps means it provides 15 watts, which means this actually can't power the entire clock. Now, it's a 3 to 5, and the 5 is the burst power. It's a surge power. So at its highest, it could provide 25 watts, but you can't run that continuously.
It would just burn out?
Well, it would get hot, and then it would burn out, and that would be bad.
And PLA doesn't have like a really high tolerance for heat.
It will melt. Yeah, it will melt your clock. So what I did was I made it simple. I used 2. I could actually probably get away with 1, because most of these lights will not be on all the time, and they will definitely not be full intensity because that's just too bright. But because I had them, and because it's a good safety margin, I put 2, which means even at non-burst current, this can give me 30 watts. So this can meet my safety requirements even if I'm not stressing these.
Right. Well, it's always good to have redundancy, and if I learned anything about you, you like submarines, which are redundancy after redundancy after redundancy.
We like redundancies. We like them. So this is what we need in order to get enough power to drive my circuit. Now remember, one of these is going to be providing power to one side of the string of LEDs, and the other one is going to be providing power through the other side. The advantage to that is, if anyone's ever played with a really long string of WS2812s, you might start to notice, like towards the end of the string, they get dimmer and they start turning, like the colors all end up brown. That's just because there's not enough power coming down the line to support those last couple of LEDs. This essentially guarantees me that no matter which light is lighting up, it's going to get all the power at once. I'm powering from both sides of the string. If it was much longer, because I've done this for our first team in San Francisco, where they wanted to have WS2812s all around their little pit tent. There was like 600. What we would do is we would tap in different UBECs at various points inside the link, because you can provide power at multiple points and make sure everything gets all the current it requires.
Okay. And you've got enough space with this project so that you can fit stuff on both sides. So.
Right. One last word. We went with a 3-button setup just because we wanted simplicity. So if you go to the side view here, Alex, there we go. And I just changed the cap color. It's not a different button, it's just a different cap. So this, if you remember from our programming episode, this one's going to control mode, this one's going to control increment, and this one's going to control decrement.
Okay.
So it's that simple. So this one will change which mode it's in. So that one tells me I'm in my set time mode. This one is sort of the animation mode, and then back to time. So it just keeps looping through. And this can also control brightness, as well as setting time, and as well as choosing which animation I want to run.
Pretty cool.
Like that one.
I like the animations.
I kind of like the Cylon one.
Which is, you stole some of these profiles from the goggles, right?
Yes. Actually, most of them. I think I only wrote 1 for this one.
They transfer well, though.
They do. You can just keep taking those code snippets and use them over and over.
Yeah, I like them.
Yeah. So next up, let's go ahead and show you how we're going to assemble all of this. But before we do that, let's take a moment for these messages.
If I may, I hate to interrupt Know How, and I'm learning a lot, of course, but if you guys don't mind, I would like to talk a little bit about how I solve my Wi-Fi conundrum. Oh, man. The worst thing in the world is that call from across the house, honey, the Wi-Fi's down. Of course, you know, I'm responsible. And, you know, sometimes I guess I could blame the ISP, but almost always it's the router. And we have a house that's spread out. I think nowadays everybody, you know, is trying to put more devices on our Wi-Fi. I have 42, I just checked, 42 devices connected to my Wi-Fi. My neighbor's Wi-Fi comes booming in. My other neighbors. So I got lots of signals in the house. It's not a surprise that Wi-Fi is a little more challenging, shall we say, than it used to be. That's why I installed Eeros, and I love them. I've been using Eeros since they came out. They were one of the first mesh, in fact, maybe the first consumer mesh Wi-Fi solution. I liked it so much I installed it for my mom back east. She was having Wi-Fi issues. And now I've just installed the newest Eero 2.0, the second generation, and it's even better. Twice as fast, they say. 2x2 MU-MIMO. It's got a tri-band now, and it is awesome. Eero started, I guess, about early 2016. I remember very much the excitement. I read about them, and I ordered one right away. They have now since then learned from hundreds of thousands of users, and that makes the Eero better, smarter, faster, and more reliable. The Eero 2 now looks the same. The base unit looks the same, the one you plug into your router. But this is what makes Eero unique and wonderful, that you then fire up the Eero software. I've got it on my iPad so you can read a little bit better. Actually, I have fewer devices connected. But see, as people come and go, stuff gets disconnected and reconnected. You put these other Eeros around. I've got 2 beacons. So in the den, I have the main base unit connected to the router. And then you position these Eeros. And these are the new Eero beacons. They're smaller. And it's great. They plug into the wall, so there's no wires. And I really like it that the Eero beacon has a little, and you may or may not use this. You can turn it off if you don't. But it has a little nightlight on it. So I put these in the halls, which is actually a good place to put your router. And I can navigate the hall. Eero periodically checks your bandwidth, as you can see, and it will even give you a graph of your internet speed and tell you how you've been doing with the internet. It's fabulous that way. You also could see what devices are connected most recently. And remember the last time I did this ad, my gym was down. Somebody had unplugged it, and it will tell you, something's wrong here. And I went and I plugged it back in. I love this. So you can create family profiles. So there's 3 of us in the family. Me, my wife, and our son, Michael, 14-year-old. Now, this is cool. So I can assign to Michael devices that belong to him, and including, his game machine, his iPad, his phone, and so forth. I give him a name. I say, these are Michael's devices. And if I'm not going to do it right now because he's home gaming. But if I press that pause button, it takes him offline. Now, that's a great thing to do when it's time for bed or time for homework. You can even do it if you have an Amazon Echo and the Eero skill on your Echo. You can even say, Michael. Actually, I don't actually tell Michael. I don't say, Michael, I'm going to turn off the internet. I just go, hey, Echo, pause Michael's internet. And then wait for it. 5, 4, 3. What happened to the internet? I love that. But another thing we can do, because, and this is a new subscription feature with the family profiles, there's also something new called Safe Filters. Safe Search, adult content, illegal or criminal content, and violent content filtering. And everybody in the house has filters against malware and spyware. It secures your network. There's a small fee for that. I really appreciate it. And but most importantly, the Eero has eliminated, honey, the Wi-Fi's down. It works great. Faster than ever, easier than ever. It's the only Wi-Fi solution that is constantly updated and improved, and I really like that. By the way, the not only does it have tri-band, it's also twice as fast, but they've also added a thread radio, and that's for connecting to low-power devices like locks and doorbells and other sensors. It's the new IoT protocol Thread, so that's also built into the new Eero second generation. And if I needed more coverage, I don't. 4,500 square foot home, this does 5 bars everywhere, including the backyard, including my cameras outside, my Ring doorbell. All of that worked fine with this. But if I needed more connectivity, I expand the house, or I want to get outside of the patio, you just add another beacon and boom. Now, we got a good deal on the Eero, the brand new Eero. For free overnight shipping, go to eero.com. And just as you check out, select overnight shipping, and then use the offer code KNOWHOW, and that'll take the cost of the shipping off. So you can get your Eero right away. You can get it day after tomorrow. Or tomorrow, I guess. Go to eero.com, select overnight shipping, and use the promo code KNOWHOW. That has another advantage. It lets Eero know you heard it here, which is good for the guys and good for the show. I love our Eeros, and I know you will too. Improve your Wi-Fi. Get your Eero today, eero.com. Now we go back to Know How. Thanks, guys.
And we're back. Okay, so Brian, we're going to show the good folk at home how they assemble the electronics to drive all this coolness.
Nice. I'm looking forward to it.
Yeah, so without further ado, hey, Alex, could you go ahead and push the magic button? Previously on Project LED Clock, we need a better name, we soldered together the LED ring and the individual WS2812 LEDs that act as the output of our clock. This time, we're going to put together the components that drive the LEDs. The heart of our project is an Arduino Nano and a tiny real-time clock module. I printed the template that's inside the base to make it easier for us to see how everything is soldered together. I'm using standard jumper wire to link the RTC to the Nano. We need to connect the 5-volt, ground, data, and clock lines from the RTC to the Nano. Power will go to the ground and 5-volt ports closest to the RTC, while data will be connected to analog 4 and clock to analog 5. This schematic will be available in the show notes, but once again, from the tiny RTC to the Nano, ground to ground, VCC to 5-volt, SDA to A4, and SCL to A5. While we're at it, let's go ahead and install power risers on the voltage in through hole and the ground pad on the other side of the Nano. Strip about 20 millimeters of insulation away from each of the jumpers and tin. These wires will be used to connect power lines from the UBEC as well as the lines that power the switches that control the clock's functions. Solder the lines to the Arduino, then slip some heat shrink over the risers to insulate the joints after we're done soldering. Put aside the Arduino and the RTC for a moment and let's start working on our power systems. We're using two 3-amp UBECs in this build, but I'd be perfectly happy using a single large capacity UBEC. We start by threading our power connectors through the back of the base, then stripping and tinning. Do the same thing for the power leads going to each UBEC. Slip heat shrink over the power leads, then solder the ground and positive leads from both UBECs to the ground and positive leads on the power connector. Slide the heat shrink back over the solder joints, then shrink the tubing to insulate. You can solder the UBECs directly to the power leads that we left running from the LED ring array, but I use 2 pairs of SEMA battery connectors to create quick disconnect points. This is completely optional, but it does make servicing and assembly a little bit easier. Additionally, I used a 2mm bullet connector to make a quick disconnect for the data line. Again, completely optional. One side of the power circuit needs to give 5 volts to the RTC and Arduino. I soldered 30-gauge silicone wires to the right side of our power circuit, then heat shrinked it. Our columns are hollow, and they have a hole at the bottom to ease the wiring. Once your connections are insulated, run the LED ring wires into the columns, out the bottom, then up till they're poking above the column. With both sides ready to receive the ring, let's get our input electronics working. The cover and button holder use 12mm by 12mm momentary switches and caps. First, straighten the pins so that they can easily fit into the slots in the cover. The button should be a perfect fit for the cover, just make sure the pins go through the slots before you push the button in, otherwise you might break off the pins or fold them underneath the button casing. Once the buttons are in place, snap on the button caps, then slide the button cover into place. If you want to make the process easier, you can hold off inserting the buttons until you're done with the soldering. The wiring for the buttons is straightforward, but it's easy to make a mistake, so pay close attention. Each button needs 5 volts, ground, aligned to one of the digital pins on the Arduino, and a 10K resistor between the digital pin and the ground line. Also, the 2 pins on each side of the buttons are connected, making our job a little easier. The circuit is as follows: 5 volt to one side, to the other side 1 pin is connected to the digital pin on the Arduino, and the other to a resistor, which is then connected to ground. Once again, the following schematic will be available in the show notes, but just for giggles, each switch has 4 pins. The top and bottom pin on each side are always connected, and all 4 pins are connected when the switch is closed. First, connect a single digital pin on the Nano to 1 pin on each switch. My code uses pins 2, 3, and 4. Next, connect ground through a 10K resistor to the same side of the switch as the digital pin. This is so that the current will flow even when the switch is open. This creates the low or off position. Finally, connect 5 volt power to the other side of each switch so that when the button is pressed, the digital pin on the Nano for that switch will receive 5 volts, or the high/on position. We need to connect 3 buttons, but that doesn't mean we need 3 sets of leads. The 5 volt and ground lines can be daisy-chained from our power risers by a set of 30-gauge silicone wires. Just make sure to put a 10K resistor between each switch and the ground wire. Use pieces of heat shrink to keep the leads from shorting should the wires move around inside the housing. With the buttons wired up, it's time to connect them and the UBEX to the Arduino for power. The 5 volt and ground wires connect to the 5 volt and ground risers from the Arduino that we created earlier in this project. However, it's not a straightforward connection. We don't want the Arduino to power the LEDs. They would draw too much current from the Arduino for safe operation. Instead, we want to be able to power the Arduino from the UBEX, but not have the Arduino feed power back to the LEDs or to the UBEX should we connect USB and not power. That's why we need diodes. Diodes only allow current to flow in one direction from one pin to the other. We need 2 of them, one for positive and one for ground. Solder them in line on the lines going from the UBEX to the power riser. Once installed, power will only flow in the proper direction. The last step is to connect the data line going from the LED array to digital pin 7. This single wire will control all the LEDs in the array, first through the 60 LED ring, then to the 26 individual WS2812 LEDs in their holders. Okay, so it's not that complicated. If they've done any of the projects here on Know How before, that should be relatively easy. It's just a little bit of soldering. I'd say the most complicated thing are the buttons, and that's just because you have to get used to them.
Yes, get used to the buttons.
It's that 10K resistor. So yeah, I mean, it's again, you can't just wire the button straight to the Arduino. You might think you can. You could try to use the internal pull-up resistors. I wouldn't. Just because they don't always work properly. So if you go to the side view, Alex,
you did a good job.
This is what the little Frankenstein looks like. So you got everything crammed in here. This just fits. I think if I were to redesign this, I might make this just a little bit bigger. Everything fits, but it's really, really tight.
Yeah, no, I mean, it looks good. You did a good job with the heat shrink on the wiring and the resistors. I mean, it looks good, and there's enough space for it as it is, yeah, but maybe a little bit more space would make it easier.
Yeah, and I will say, remember, you can daisy chain this. So you don't need a lead, a positive lead and a negative lead for every single one of these buttons. That's why I have those risers. So the risers split off, and then inside, in line, each one of the ground wires, you've got that little 10K resistor, so it gives you the signal for the low.
Right.
And remember, again, the reason why we do that is because if you don't have that 10K resistor, it means that when you're not pressing the button, there's no current.
Right.
And no current isn't off. No current just means I don't know what's going on. The Arduino can't measure no current.
Right.
The Arduino can measure low current, which is why when I have my finger off the button, it's going from the digital pin into ground. And that's just enough current so the Arduino knows, okay, this is my low state. When I push the button, it shorts it to the 5 volt line, and that says, oh, that's a lot of current.
Right. It needs a way of being able to tell a difference.
Yeah, yeah. Okay. And remember, the example that we used before is, imagine you're in a room that's completely dark and you can't hear anything. Well, you have no reference. If you can't feel anything, you have no reference about where anything else is. But if you are able to touch the wall, then you could just follow the wall, right?
Right.
And you have a reference point. Well, that's what that resistor is. It's a reference point.
Right. And if that state changes, then you know you're, well, I guess if you're in that scary room,
Precisely.
then you're in a different part of the room. Right, yeah.
There we go. Yeah, so that's how we assemble that. Now, in the next episode, what we're going to do...
That example is terrifying. a room with no light and you can't hear anything.
We should do a VR simulation. So this is what it looks like inside an Arduino button.
Yeah. It is terrifying.
This
is a thing of nightmares.
This is what we think of here, folks.
Sorry.
This is know-how. We will be assembling everything. So we've got the LED ring. We've got the base. We are going to have the buttons. So in the next episode, we're just going to try to put everything together because we want to give people a nice let's solder feel. We're going to sit down at the big table. We're going to have fun.
Nice.
Open a couple of beers. No, not beers.
Well, maybe one.
I only drink whiskey.
Well,
Drink whiskey.
that's not a bad idea
I like
either.
the smell of whiskey. I don't like the taste.
Which works out for me because then I get all your little the whiskey bottles that are
After
opened.
I've opened them and smelled them.
It's okay. They still taste all right.
Now, we did want to do a little something, which is to inspire you to make this better. Because remember, what we love the most is when you take one of our projects and you turn it into something more spectacular. Like, for example, a while back, we had someone who took our steampunk goggles, did a little something, added a couple of lectures, and it looked beautiful.
It's cool.
We want you to do that. That's why I'm giving you all the templates in addition to the STL file so that you can take it and run with it. We want to see what you come up with. And one of the things that maybe some bright person might be able to work into their design is a way to get rid of all that wiring.
Oh.
There is a way to do that, Brian.
Yeah, you sure?
Yeah, we're going to talk about that. But first, let's go ahead and take a moment for these messages.
It's time for FreshBooks. Hello, everybody. Thank you for letting me interrupt Know-How. Thank you, gentlemen. But I want to tell everybody about well, I've told this story a million times. I don't need to tell it again. When I was a young freelancer a few years ago, and I was going to Canada to do the TV show once a month. I'd go for a week and do a call for help up in Toronto. And I would have to invoice them for my time, for my expenses, for my food and travel, all that stuff. And it was such a pain. I just hated it. Amber MacArthur, my co-host at the time, she told me, you got to try FreshBooks. This is this brand new company in Toronto. They make it so easy to send invoices. And now here we are, 10 years and 10 million users later. That's how many people use FreshBooks today. I was the first, practically. It is just a great solution. It makes it easier to invoice. And, of course, you got to invoice to get paid, but also it makes it easier to understand where you stand, where your business stands. And in effect, it's accounting because if you think about it, if all the accounts receivable go through the invoices, all the outstanding invoices, all the paid invoices, there's your income. All your expenses go through. In fact, you use the FreshBooks app to take pictures of receipts, get them right into the invoice. You know what your costs are. What your income is, you know whether you made any money or not. And that's what's great. You go to the FreshBooks front page now. They didn't have this when I was using it. This is the brand new front page. You'll know your profits. You'll know how you're doing. You know which invoices have been paid, which have not been paid, which have been viewed, and that is handy. No, because sometimes some clients will say, well, I didn't get your invoice. Yeah, you did. You opened it 2 days ago. I know you got it. You'll know that. If they don't pay, you could have automated payment reminders. You could set up automated payments as well as automated invoicing. On average, FreshBooks users get paid 11 days faster just because it works. And it turns out your clients, if you make it easy for them, will pay you faster. They really will. You can brand, of course, your invoices. They've got your company logo on it. They look really great. You could send recurring invoices if you want automatically. Take all the pain out of it. Automatic late fees. FreshBooks also integrates with stuff you might use, for instance, Stripe, Shopify, Gusto, Acuity Scheduling. And they're always adding features. This is what I love about FreshBooks. Every time you go to your site, you'll find there's something new there. You can now create and send estimates to your clients from the FreshBooks iOS app. Oh, by the way, they got great apps. Send invoices to multiple people in an organization and say, you're the secondary contact. That's always handy. You know, if the accountant says, I didn't get it. I say, well, I also sent it to your CEO. You might want to check. It gets their attention quick. I sound like I had slow pay clients. I didn't. Rogers was great. I was a slow invoicing customer. I would put it off because I hated doing it. Rogers would pay right away. But I did learn an important lesson. If you don't invoice, you don't get paid. Forbes Small Giants list for 2017, rightly so. And I am so happy that I discovered them with the help of Amber MacArthur. FreshBooks.com/knowhow. You could try it free for 30 days right now. Just put know-how in the How Did You Hear About Us section. FreshBooks.com/knowhow. Look, if you're a freelancer or a small business, just try it. 30 days free. And I think you'll agree, it is a revolution in the way you do business. FreshBooks.com/knowhow.
And we are back. Okay, so Brian, wiring, I like it because I am ADD and I can have my favorite couple of shows on as I'm soldering, and I like the lead fumes. They make me feel better. But
and they make you act a little different.
They do.
Too.
They do. But that's not necessarily what you want. Sometimes what you want is you want sort of a plug and play approach. One of the things I thought about doing, like for example, for the little frame here, is why not make it a pogo plug instead, so that I don't have to worry about the wires twisting. Or for the wiring inside the base, why do I have to worry about running wires up the channels if there was a way to bake all that wiring into the printing process?
No, you can't do that.
Yes, you can. We stopped by Maker Faire not too long ago, and we found a company that was selling electrified filament. So you've already got your money invested in a good 3D printer, but now you want to start playing with electronics, and you don't want to buy one of those pick and place or specialized 3D printing machines that cost thousands and thousands of dollars. Well, what if I told you that you could use your existing investment and print your circuits? That's why I'm here at Multi3D with Shenrong, who's going to explain what their Electrify filament can do for you. What is this?
Yeah, we call it electrified filament, which is a conductive filament that is 100 times more conductive than anything else that you can buy from the market. Yeah.
But the key here is that I could put this into my existing 3D printer. Like, for example, what's the temperature I have to get my hot end up to in order to extrude this properly?
We prefer printing these filament at like 140 to 160. And yeah, there are more information actually on the website you can find out.
But basically that means that any ABS, any PLA printer will be able to do this just fine.
Exactly, yes.
One of the things that I saw you demoing earlier is that once I get the filament down on whatever 3D print I have, I can actually reflow it. I can use a soldering iron to move over some of the material, so I don't have to do big blobs of solder. I can literally have a project board that I place my SMD components, resolder, and done.
Yes, that's how we actually form the contact between the LED and the conductive filament. Yeah.
Now, this is a concept that has been tried several times. What did you do to make this work properly?
We have a metal filler as a conductive filler. So as you can see that all the other conductive filament are all carbon-based, but metal we think is much more conductive. That's our recipe.
All right, now our audience is going to want to know how complicated can they get, because I mean it's one thing to hook up some blinky LEDs, but if I wanted to do more complicated circuitry, if I wanted to actually get my paths a little far down, how far could I go using the Electrify filament?
Our strength for this filament actually is more towards this LED project, and it's also depend on the 3D printer that you're using. But if you want to build like complicated circuit, so you probably want to use a smaller nozzle size, right, to print thinner traces or more complicated. But it depends on the 3D printer that you're using.
I can tell you I'm looking forward to trying some of this on our Maker Show. Could you please tell our audience where they can find you, where they can find Multi3D, where they might be able to buy some Electrify filament, and of course, all the addresses to make that possible?
Sure. Our company name is called Multi3D. You can find us at www.multi3dllc.com. You can buy this filament directly from our website and also from Amazon and eBay as well.
Thank you very much for speaking with us. Thank you very much for sharing your tech. And that's Multi3D. It's electrifying.
Thank you.
Get it? Electrifying?
I get it.
Pass power.
That is bad.
So, okay, yeah.
That joke is bad. You should feel bad. But that electrified filament is super cool.
It's very cool. And you know, the thing is though, in order to properly use that, I'd have to upgrade my printer to a 2-head, because you don't. it would really constrain you if you had to like print and then lay down a second
Change
design on top
filament?
of the print.
No,
And
that's totally impractical. But you have always looked for excuses to upgrade, so there you go.
There you go. That's just one of the possibilities. We're actually be coming back next week and looking at another way that I could use the same design, the same components, the same individual pieces, but turn this into a beautiful, beautiful, shiny icon of awesomeness.
that has like a heavenly glow about it with
it
the just sitting there. Okay.
You'll see it. It's a machine that I'm hoping to get in the near future that will change the way we do 3D projects on Know How, Brian.
And then that's when you like turn to the single.
Dramatic Padre.
Yeah.
Now, folks, we know that this has been a lot of information. We want to make sure that you get the show notes because we do the step-by-step instructions for assembling the base and actually assembling the entire clock. We also want to give you the links to things like the electrified filament. You're going to be able to find all of that in our show notes. And Brian, where do we keep those things?
Well, we hide them in a secret place called twit.tv/KH. And not only can you find the show notes, which will have all the links to the parts that we talked about today for building this project, but you can find ways to subscribe or download the episode, which you'll want to do because this is more than a 4-parter.
This is a 5-parter.
This is a 5-part episode. So download them and then stitch them all together.
Put them all together and then just watch them on a loop.
Yeah.
And especially when we get to the coding episode, just copy everything from the screen.
Right.
That's what you like for them to do.
And just pause it, copy it from the
bad
screen.
person.
And if you watch it enough times, you'll be able to build a better clock than Padre, and you can make them feel bad and post it. Well, where would you post it, Padre?
You'd post that in our socials, specifically in Google+. Just go to Google+, look for Know How. Very short approval process so we can keep out the spam accounts. But once you're in, you get access to over 11,000 Kitas. That's our know-it-alls. People who can help you with your project. Maybe people with whose project you can help. If you're an expert, if you're a newbie, if you just like seeing what other people build, you're going to want to check out our group. Again, that's Google+. Just look for Know How.
But that's not the only place you can find us. If you want to see what we're doing behind the scenes or what projects may be coming up in the future, you're going to want to follow us on Twitter. I am cranky_hippo.
And you're going to find me at PadreSJ. And you can find the third member of our group. Yeah.
What?
Billy. I call him Billy.
Billy.
He reminds me of the kid from Billy and Mandy.
Billy.
Yeah. So you can find Billy at twitter.com/ANELF3. An elf. There we
He's
go.
over there in
Thanks,
the
Billy.
abyss.
You do such a good job, Billy.
Excuse me, Padre. It's pronounced Alex.
How do we get that wrong?
No, I think he's wrong.
I'm pretty sure it's Billy.
I'm pretty sure it's Billy. Until next time, I'm Father Robert Ballester.
And I'm Brian Burnett.
And now that you know how,
Go keep track of time. Oh, I broke it.
goes the other way.
Oh, no.